the previous sections, we have dealt with important computational problems. For example, the search problem and the sorting problem. And we compared algorithms for those problems against each other. In the latter section, we have done something more theoretical. We got to know a few algorithm models. As discussed there, we need those algorithm models in order to do abstract investigations on complexity. It is not sufficient to do such investigations, for example, with Pascal programs or PHP source codes. We need a unified, universal way of specifying algorithms, and this is what we call an algorithm model. Now we are choosing one of the discussed models, one of the most practical ones. This is the Turing machine. We, programmers, like machines very much, right? In fact, the Turing machine is a very simplistic computer, much simpler than a real computer, in fact. Let's see what building blocks the Turing machine consists of. On the one hand, it has a so-called tape. On this tape, we store data. The tape is divided into cells, and each cell, one unit of information can be stored. Over the tape, a so-called head moves. This head is located over one of the cells in every move. The head is reading the data from the current cell, and furthermore, it can override this data and then decide in which direction to move, one cell left or one cell right, or to stay unmoved. So this is the tape. Another building block is the control unit or controller. As we all know about computer architectures, every computer has a CPU, or at least one CPU. Some computers contain several CPUs. Other ones utilize their GPU as well in order to enhance computational power. Or several hardware elements cooperate in order to control our computer. Since the Turing machine must be universal, we consider the controller as a black box. In other words, we don't care about what concrete elements are responsible for the control. For us, the controller is a single device. It's a black box. Its interior cannot be seen. We can determine only one thing about the controller. Has its state just changed? We know in which state the controller has been. And we can detect if it is in another state in the next moment. This is it. So this is the controller, and it works very simple. Okay, what is missing? Well, obviously, a third component is still needed for the Turing machine, and this is the software. The software which specifies the following behavior. When should the controller switch state? Shall we override the symbol being read from the tape? Furthermore, in which direction should the head move? Left, right, or should it stay unmoved? So one can say that a Turing machine is really similar to a computer. Yet, as mentioned before, it is a theoretical model. So in what sense is it theoretical? In only one aspect, and this is the tape. Its tape is infinite. So this is why Turing machines can be considered to be fictional. Their memory is not limited. Any amount of information can be stored on the tape. Obviously, in real life, such a machine cannot exist. Is the Turing machine really universal? Can it model any algorithm? Yes, it can. And this was proven by computer scientists. The Church-Turing thesis claims that the Turing machine is indeed a universal algorithm model. anything that can be solved by a software, by an algorithm, it can also be solved by a Turing machine. This is a very strong claim. So, in the next section, you will be acquainted with Turing machines. We will define what a Turing machine can in fact do with a computational problem. Then we will check if the Turing machine can be boosted, that is, extended. In the subsequent sections, we will do investigations on extensibility primarily in the following sense. Can the Turing machine computations be parallelized in some manner? For instance, what happens if a Turing machine has more than one tapes? We will store information on several tapes. Each tape will be equipped with an own head. All those heads will be able to read, write, and move independently from each other. So the big question here is if the multi-tape Turing machine is more powerful than the single-tape one. Okay, I'm not answering this question right now, but you will get the answer at the end of the subsequent sections. So let's see what path leads us to this exciting answer.